In this video, we will practice solving rational inequalities. This is AP Precalculus topic 1.8. Again, this is a practice video. If you did not see the previous video where I introduced all of these concepts, you should probably watch that first. This video will make a lot more sense if you do. You can either click the link that appears in the upper right-hand corner or find the link in the description. If you appreciate this content, please don't forget to hit that like button. Before we get into solving rational inequalities, let's warm up by finding the zeros of rational functions, which is the first step. A rational function will equal 0 where the numerator is equal to 0. So for number 1, the zeros are x equals -3 and +2. Similarly, if we set x squared equal to 0 and solve, we just get x equals 0. The zeros only come from the numerator. For number 4, we're going to have to factor this first. So this is going to factor down as x times x. 20 can either factor as 4 times 5, or 2 times 10, or 1 times 20. Let's start with 4 and 5. We need to get a middle of -1. So we're going to need a +4 and a -5. So the zeros, setting these equal to 0, will be -4 and +5. Number 5 is also factorable. This is the difference of two squares, which factors as x plus 3 times x minus 3. So the zeros for number 5 are x equals -3 from the first factor and +3 from the second factor. The graphs of several rational functions are given below. Use the graphs to solve the following inequalities. Number 7, where is f of x greater than 0? That's going to be above the x-axis. Take note of the x-intercept here at -1. Because we only want values where f of x is greater than 0, not equal to 0, I'm going to put an open circle right here that leaves out the endpoint. So above the x-axis is going to be this part of the function, and this entire branch up here is also above the x-axis. Looking at this first interval, f of x is greater than 0 from -infinity to -1. We will use a parenthesis to show that the -1 is not included. That goes along with this open circle. Looking at this other branch up here, I'm going to put a union symbol, and this interval goes from 0 to infinity. The 0 is not included. This is a vertical asymptote, and the graph never touches it. So we're going to leave that out. But from 0 to infinity, f of x is above the x-axis, thus greater than 0. Where is g of x less than or equal to 0? Let's start with where it's equal to 0, right here at x equals 1. Because we want values where g of x is equal to 0, I'm going to make this a closed circle. Now the less than part means below the x-axis, so it's going to be this part right here. This is the only part of the function that is less than or equal to 0. This interval, looking at the x values, goes from -1 to +1. I will put a parenthesis on the -1 because this is a vertical asymptote at -1. The function g of x never reaches this asymptote, so -1 cannot be included. I will put a bracket on the +1 for the same reason that I put a closed circle. I want this point to be included because I want values where g of x is less than or equal to 0, and this is where it is equal to 0. Where is h of x greater than or equal to 0? Let's start off with the equal to 0 part. Kabam and kabam. Closed circles because equal to 0 should be included. Now the greater than part means above the x-axis. So that's going to be this interval right here. It's going to be this interval right here. And this entire branch over here, all above the x-axis. So this first interval goes from negative infinity to negative 2. With a bracket, for the same reason I have a closed circle. Union. This middle interval goes from negative 1 to 0. The negative 1 gets a parenthesis because this is a vertical asymptote and the function never actually touches it. The 0 gets a bracket. For the same reason I put a closed circle there, or equal to 0. This is included. Union. And this last branch right here goes from 1 to infinity with a parenthesis on the 1 because it's a vertical asymptote and the function never actually touches it. So that's number 9. Okay, now let's solve some rational inequalities. I'm going to refer to this left part of the inequality as f of x. The first step is to find and list off the zeros of f of x. So I like to label it like this. Where does f of x equal 0? A function will equal 0 only where the numerator is equal to 0. So that's at x equals negative 2. We also need to find another critical value, which is where f of x is undefined. A rational function will be undefined where the denominator is equal to 0. So that's at x equals 1. Now we make a sign chart. When you make a sign chart, you make a row for every factor. So we have the numerator and the denominator. That'll be 2 rows. This first vertical line is just for labels. Other than this, I need a vertical line for every critical value. I'm going to put both of these critical values across the top in order from least to greatest. This is a number line. Label your sign chart. I'm just going to call this f of x. This first row will be for the factor in the numerator, and the bottom row is for the x minus 1. From least to greatest, the negative 2 goes first, and the positive 1 goes second. Now we need to decide if these factors are positive or negative in each interval. The x plus 2 factor gave us a 0 of negative 2. So this is the only place where x plus 2 might change signs. In this case, x plus 2 is negative to the left of negative 2 and positive to the right. If that's not obvious to you, just pick some values to test. For example, a number to the left of negative 2 would be negative 3. If I plug in negative 3, that would be negative 3 plus 2, that's negative 1. That tells me that we're negative over here. A value to the right of negative 2 would be 0, for example. If I plug in 0, I get positive 2. So, negative on the left, positive on the right. Similarly, the factor of x minus 1 gives us a 0 of positive 1. This factor is negative on the left and positive on the right. The overall sign of f of x will depend on how many minuses you see. An even number of minuses gives you a positive value. An odd number of negatives is negative. And of course, all positives is definitely positive. We are looking for the values of x that will cause f of x to be less than 0. So we want the interval where f of x is negative. Should we include the endpoints? Well, no. We are only looking for the values of x that cause f of x to be less than 0, not equal to 0, negative 2, and definitely not where it's undefined. So we will show that the endpoints are not to be included by using parentheses. So I'll write the actual solution down here, negative 2 to 1. So this is the solution in interval notation. I'm not going to do this every time, but I am going to write this as an inequality just to show you that you can. So you could write this as negative 2 is less than x, which is less than 1, for example. Okay, number 11. Where does f of x equal 0? That's where the numerator equals 0. That's x equals 3. Where is f of x undefined? That's where the denominator is equal to 0. X equals negative 5. Set up your sign chart like this with a row for each factor. Be sure to put your critical values in order from least to greatest. X minus 3 gave us a 0 of 3. This factor will be negative on the left and positive on the right. X plus 5 gave us the 0 of negative 5. It will be negative on the left and positive on the right. The overall sign of f of x will be positive in the first interval because of the even number of negatives. It will be negative in the middle interval because of an odd number of negatives, and positive in the last interval. We are looking for values of x that will cause f of x to be greater than 0. So the solutions will be in the intervals where f of x is positive. That's here and here. We will not be including any endpoints this time because we only want values that will cause f of x to be greater than 0, not equal to 0, not undefined. We will show that we are leaving these out by using parentheses in the solutions. So this first interval is from negative infinity to negative 5, and then union 3 to infinity. Here's how you would write that same solution as an inequality. Look at number 12. Where does f of x equal 0? Well, that's going to be where the numerator is equal to 0, but because there's a constant there, that means there are no values of x that will cause this fraction to equal 0. But there are other critical values we must consider. Where is f of x undefined? That's where the denominator is equal to 0, which happens at x equals 1. Set up your sign chart like this, with your two factors and your one critical value. The negative 3 is negative in every interval. The x minus 1 will be negative to the left of 1 and positive to the right. F of x will be positive in this first interval because a negative times a negative is a positive, and it will be negative in the second interval. We are looking for the values of x that will cause f of x to be greater than or equal to 0. So we will find solutions in the interval where f of x is positive. However, well, I started to say we will also include any values that will cause f of x to equal 0 because we want or equal to 0. But this number 1 is not such a place because f of x is actually undefined here. So you will never include an undefined value in the solution. We will show that 1 is not included by using a parenthesis. So this interval goes from negative infinity to 1. So this is the solution in interval notation. Number 13. Where does f of x equal 0? This will be where the numerator is equal to 0, which is simply at x equals 0. Where is f of x undefined? That's where the denominator is equal to 0, which happens at x equals 4. On the sign chart, we will have a row for the x and a row for the x minus 4 squared. Make sure you include that exponent. It is important. Put your critical values in order from least to greatest, 0 and 4. X is obviously negative to the left of 0 and positive to the right. X minus 4 squared is positive in every interval, because when you square even a negative number, it becomes positive. F of x will be negative in this first interval because of the odd number of negatives, and it will be positive in the remaining intervals. We are looking for the values of x that will cause f of x to be less than 0. In other words, negative. Not equal to 0, so we will not include the 0 itself. We will show that 0 is not included by using a parenthesis. So this one interval goes from negative infinity to 0. So that's it. Easy peasy. Where does f of x equal 0? That's wherever the numerator is 0. So x equals 1 and x equals negative 6. Where is f of x undefined? That's where the denominator is equal to 0. So x equals negative 2. Setting up the sign chart, we have a row for every factor. X minus 1, x plus 6, x plus 2. We put the critical values in order from least to greatest. So negative 6, negative 2, and positive 1. X minus 1 gave us the 0 of 1. It will be negative to the left and positive to the right. X plus 6 gave us the 0 of negative 6. It will be negative to the left and positive to the right. X plus 2 gave us the 0 of negative 2. Negative to the left, positive to the right. F of x will be negative in the first interval because of the odd number of negatives, positive in the next interval because of the even number of negatives, and similarly it will be negative here and positive here. We are looking for the values of x that will cause f of x to be less than or equal to 0. So the solutions will be in the intervals where f of x is negative. We will include any endpoints where f of x is equal to 0, because we want the values of x that will cause this to be less than or equal to 0. So I will put a bracket on the 1 and the negative 6 when I write the solutions. I'm going to put it now so I don't forget. So I'll need a bracket on the negative 6. I will need a bracket on the 1 when I do this interval. However, the negative 2 will get a parenthesis when I do this interval, because that's where f of x is undefined, and we don't want that. We want less than or equal to 0. We don't want undefined. So we will show that we are leaving this value out with a parenthesis. So the first interval goes from negative infinity to negative 6 with the aforementioned bracket. And then union negative 2 to 1, and there's another bracket for you. That's it. Number 15. Where is f of x equal to 0? That's where the numerator is equal to 0. So that's going to be at x equals 3 over 2 and x equals negative 4. Where is f of x undefined? That's where the denominator is equal to 0, which is at x equals 0. Set up your sign chart like this, with a row for every factor, including this x squared, and with your critical values in order from least to greatest across the top. This is a number line. So 2x minus 3 gave us the 0 of 3 over 2. So this is the only place where this factor might change signs. Normally I just say it's going to be negative on the left, positive on the right, because that's usually what happens. And maybe it will happen again, but this does have this extra 2 here, so let's take a moment and think about it. So let's see, to the left of 3 over 2, this is 1.5. So 0 is to the left. If I plug in 0, then that's just going to leave negative 3. So yeah, it is going to be negative on the left. I said this is 1.5. I could have used 1 would be on the left. If I plug in a 1, that would be 2 times 1, which is 2, minus 3, which is negative. Will it be positive on the right? To the right of 1.5 would be 2. If I plug in a 2, that's 2 times 2, that's 4, minus 3 is positive 1. So, as it often is, we get negative on the left, positive on the right. Anyway, x plus 4 gave us the negative 4. This factor is negative on the left, positive on the right. X squared gave us the 0, but that doesn't matter. Because it is squared, this factor will be positive in every interval. F of x will be positive in this first interval because of the even number of negatives, and it will be negative in the next interval, negative in the next interval, and positive in the last interval. We are looking for the values that will cause f of x to be greater than or equal to 0. So the solutions will be in these intervals where f of x is positive. Because we want greater than or equal to 0, we should include any endpoints where f of x is equal to 0. So I will show this by putting a bracket on the 4 and a bracket on the 3 over 2. So the solutions are from negative infinity to negative 4, bracket, union, bracket, 3 over 2 to infinity. These next 4 problems will require some factoring first. X squared minus 9 is the difference of 2 squares, which factors as x plus 3 times x minus 3. So now we have this. Where does f of x equal 0? That's at x equals negative 3 and x equals positive 3, where the numerator is equal to 0. Where is f of x undefined? That's where the denominator is equal to 0, which is at x equals negative 2. Set up your sign chart like this. The x plus 3 gave us the negative 3. This factor is negative on the left, positive on the right. The x minus 3 gave us the positive 3. It will be negative to the left and positive to the right. X plus 2 gave us the negative 2. It will be negative to the left and positive to the right. F of x will be negative in the first interval because of the odd number of negatives, positive in the second interval because of the even number of negatives, negative in the third interval, and positive in the fourth interval. We are looking for where f of x is greater than 0. That's going to be where f of x is positive. Should we include any of these endpoints? No. We are not interested in the values where f of x is equal to 0 or undefined, only greater than 0. So we will show that the endpoints are not included by using parentheses, like this. So this first interval goes from negative 3 to negative 2, all parentheses, union, and the second interval goes from 3 to infinity. We need to factor number 17 before we get started. X squared will only factor as x times x. 10 can either be 2 times 5 or 1 times 10. I'm betting on 2 times 5. Inner plus outer must equal middle. So to get a negative 3, I'm going to need a positive 2 inner and a negative 5 outer. So we factored it. f of x will equal 0 when the numerator equals 0. That's at x equals -2 and x equals +5. F of x will be undefined wherever the denominator is equal to 0. That's at x equals -8. Set up your sign chart like this. X plus 2 gave us the -2. It'll be negative to the left, positive to the right. X minus 5 gave us the 5. Negative to the left, positive to the right. X plus 8 gave us the -8. Negative to the left, positive to the right. Look at the odd number of negative signs. F of x will be negative in this interval, positive in the next interval, negative in this interval, positive in this interval. We are looking for where f of x is less than 0. In other words, where f of x is negative. We will not include any of these endpoints because we are not interested in where f of x is equal to 0 or where it's undefined. Only less than 0. We will show that the endpoints are not included by using parentheses around them. So this first interval is from -∞ to -8. And then union -2 to 5. Let us factor number 18. X squared plus 1 does not factor. The sum of two squares is unfactorable. So we will just leave this as x squared plus 1. But this trinomial will factor. X squared will factor as x times x. 9 will either factor as 3 times 3 or 1 times 9. Let's go with 3 times 3. Inner plus outer must equal the middle. So I need -3x and another -3x to make -6. Also, -3 times -3 is +9. Now that I notice that this factor is repeated twice, I would rather rewrite this as x minus 3 quantity squared. F of x will equal 0 where the numerator is equal to 0. That's going to be at x equals 3. F of x will be undefined where the denominator is equal to 0. But the denominator will never equal 0. When you square something, it's always going to be positive. Or at the very least, it's going to be 0. It'll be greater than or equal to 0. So if you take something that's 0 or greater, and then you add 1 to it, it's always going to be positive. So this expression can never be anything less than +1. So it'll never be 0, it will never be undefined. So sign chart. Set up your sign chart like this. X minus 3 squared will be positive in both of these intervals because when you square even a negative, it becomes positive. We already discussed why x squared plus 1 will always be positive. So that means f of x will be positive in both of these intervals. Does that mean that the solution is going to be -∞ to +∞? Nope. That would accidentally include the 3. And 3 is where f of x equals 0. We only want where f of x is greater than 0. If this had been greater than or equal to, then the answer would be -∞ to +∞. But it's not. So we need to write two separate intervals. -∞ to 3, parenthesis, and then union 3 to infinity. Alright, that's all real numbers except for 3. Let's do one more of these and then we are going to switch gears. (3x²). Actually, let me slow down a little bit. Students have trouble factoring things like this, a trinomial that has a number other than 1 in the front. So watch this very carefully. 3x squared will factor as 3x times x. Alright, I always just start with that first term. Now I'm going to skip the middle for now. Looking at the 8. 8 can either factor as 2 times 4 or 1 times 8. Right now I don't know which one it's going to be. I always start with the numbers that are closer together though. So I'm going to start with 2 times 4. Inner plus outer must equal the middle. Right now, inner is 2x. Outer is 12. That's really big. Too big. I can control the signs, but there's no way I'm going to pick the signs on 2x and 12x that's going to give me a middle of negative 2x. So let's try switching the 2 and the 4. Inner plus outer equals middle. Inner is now 4x. Outer is now 6x. This is looking much better. To get a middle of negative 2x, I need a positive 4x and a negative 6x. So that means a positive here for the positive 4x and a negative here to make a negative 6 outer. Also, positive 4 times negative 2 is negative 8. F of x will equal 0 where the numerator is equal to 0. So that's going to be x equals negative 4 over 3 and x equals positive 2. F of x will be undefined where the denominator is equal to 0. So that's going to be at x equals negative 1. Set up your sign chart like this. 3x plus 4 gave us the 0 of negative 4 over 3. It will be negative to the left, positive to the right. X minus 2 gave us the 2. It will be negative to the left, positive to the right. X plus 1 gave us the negative 1. It will be negative to the left, positive to the right. F of x will be negative in the first interval because of the odd number of negatives, and it will be positive in the next interval, negative, and positive. We are looking for where f of x is less than or equal to 0. So the solutions will be in the intervals where f of x is negative. Because we want the values that will cause f of x to be less than or equal to 0, we should include these two values where f of x is equal to 0. And we will show that when it is solution time using brackets. So I'm going to put them down now so I don't forget. So I'm going to have a bracket on the negative 4 over 3, and I will have a bracket on the 2. But I will have a parenthesis on the negative 1 because we still don't want to include any values where f of x is undefined. So this first interval is from negative infinity to negative 4 over 3, bracket, union, negative 1 to 2, bracket. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.